First of all, I just want to thank ForwardJS for having me. This is my first conference talk, so we're going to see how it goes. Nothing like a little self-deprecation to start a half-hour talk. Before drinks. Okay. So let's go. So before I introduce myself, I just want to tell a story. A couple months ago, I started a new project, and as I like to do, and probably a lot of you like to do, I went into the existing code base to see what parts of my UI existed and what parts I needed to build from scratch. I was poking around these different, folders and files, and I started to notice that we had, like 5 different buttons. They all had the word button in them, but they all had, a completely different name. And I was looking through these buttons to figure out what they do, and they look pretty similar. They're different colors, similar size. They all do something when you click it. I mean, what else is a button supposed to do? But all of the functionality for every button was built into the component itself. And I thought to myself, why can't we make this more generic or general? Why can't every button look the same and behave the same and then just kind of be told what to do and not have to care about its specific use? Why didn't we make it a reusable UI component? Now, I've worked with reusable UI components a lot. At my old company, AdRoll, it's an ad tech company here in the Bay Area, we even went so far as to build a whole library of reusable UI components. So beyond just making code easier to share from project to project and also just abiding by the engineering mantra of don't repeat yourself, why would you go through the pains of building multiple components and then figuring out how to build them into a library? It's just making our lives harder, right? The first reason we decided to do this was that at AdRoll, we were a growing company. We had new engineering resources joining, we had new products that we wanted to build. And as these new engineers were joining and we had new products, we were also trying to break out of the monolith. So we just ended up having lots of new repositories for all of our projects. And over time, teams became more loosely coupled, and they could start with new blank slates, pick the framework or the build system that they wanted to use in their project. At the same time, our design team and our product teams were trying to unify the experience of our products so that as a user was trying to use them, it would feel like one cohesive experience and they didn't get lost in a myriad of dashboards. But this is despite the fact that all of our teams were building these products across multiple code bases, using different build systems. So having a library allowed us to not only implement the feature as design wanted it and maintain it going forward, but also to share it really easily across code bases. Hi, I'm Mars. I'm currently a senior software engineer at Netflix, and I don't know if you know this, but I really like reusable UI components. Yeah. And I wanted to share today with everyone some of the best practices I learned while building these components and continuing to build these components and also making them a library for others to use. So we're going to go over today how you can write the components themselves, but also how you can distribute them across teams. Before going forward, I just want to clarify really quickly what I mean by a reusable UI component. As many of you probably know, we're going to talk about React components as well. But we're not talking about the individual React components. Instead, I want to talk about a reusable UI component as a superset of React components that comprises a functional unit on a page. That's a lot of technical words. So it's basically just something that a user can interact with. So let's say you have multiple products and you want to navigate between them. You have a nav bar. That itself will probably be comprised of multiple React components inside of it, but it itself is the larger reusable UI component that I'm going to be talking about today. So why did we choose React to write our reusable UI components and create our library? The first reason is that React uses JSX, which is a JavaScript syntax extension. I'm going to assume that most of you are familiar with it, so I'm not going to show any code. But it looks a lot like a templating language, but it also has the full power of JavaScript. So what that means in the context of building reusable UI components is that when you're building a library, you can have the business logic for your component and the markup live in the same file. So if you don't have to deal with any extra templating files, whenever someone tries to use your component, they have fewer files they have to worry about. And I don't know about you, but when I'm downloading a third-party code, I generally like to deal with as few files as possible. Generally just one. That would be nice. So the second reason we chose React was that it's a declarative framework. So that just means that the markup is a function of the input. And here, React, what I mean by input is React state and props that can be passed into React components. React state allows individual React components to handle all of the user interactions that are occurring in their domain without having to communicate to the parent project or the parent component. Having props means that React components don't need to care about the data that they're rendering or where it came from or what it looks like. So between state and props, it means that our reusable UI components can handle the behavior and the user interaction without having to communicate with the parent project, but they also don't have to care at all about where the data came from. And this is important when you're building a library because different teams may be using different API endpoints and the data may be in a different structure. You're basically going to accommodate all sorts of use cases if you deal with your data in the form of props to your reusable UI components. The third reason we chose React, and this is not something that it explicitly advertises, but it's something that we needed for our components, was that the React components themselves can be easily ported into different frameworks, as opposed to the other way around. So, for example, you can use a React component if it's built the right way in a backbone view, but you can't necessarily use a backbone view in a React component. And this has a lot more to do with how you set up your build system and distribution of your components than the code itself. But it's pretty important when you're trying to share components between teams. And we're going to talk about that a little bit later. Okay, on to some code now. So I learned two major lessons when you're building these reusable UI components and trying to share them between teams. The first one is that your reusable UI components should be self-sufficient. And when I say self-sufficient, I mean that your components should do one thing, they should do that thing well, and they should do it consistently. And they should also do it independently of the parent project that someone is using. So it doesn't matter what the application architecture around the component is. The second thing I learned is that they need to be easy to integrate with. So it should be really straightforward for other developers to understand how to use your component, and also really straightforward about what the expected behavior is. So as a developer of a component, the burden is on you to basically make it stupid easy for someone else to use it. Especially if you're creating a library. The idea is to drive adoption. So if no one's using your library, then it's going to have a really hard time generalizing to your, or talking to your manager about why you spent so much time working on this. So these 2 points here aren't specific to React. They're more general ways of thinking about building components that you plan on sharing and standardizing on. So if you're asking yourself about how can I apply what I hear today to other frameworks, I want you to take this slide away. So I'm going to use an example for this talk. And just as a quick disclaimer, the code and the architecture and the use cases that I talk about here aren't something that we use in production at Netflix, but it looks a lot like the Netflix UI. So does anyone here recognize this? Okay, we've got some hands, mostly Netflix employees. Okay, so this is our back-of-the-box component, or as we lovingly refer to it, the Bob. So whenever you log into your Netflix account, you're probably going to see, a row of movies or TV shows, just basically a list of things that you can watch. And when you click on it, it's going to expand it to something that looks a lot like this. We call it the back of the box because it's like the back of the video box from, the olden days when we had video stores. So it's going to have a title, it's going to have a cover image, and it's going to have a short description. And depending on the type of content, it's also going to have these tabs here at the bottom. So the idea behind this being a reusable UI component is that we want the UI to feel the same no matter what device you're using or no matter what type of content you're looking at. So for example, you might open the back of the box on a phone, TV, or your laptop. But also, it might look a little bit different if you're looking at a TV show. So here, this is a movie. But for example, you might have a TV show, and you might add an additional tab that says episodes or seasons or something like that. And the consistent behavior for this component that I'm going to talk about is the tab navigation. So here at the bottom, when someone clicks on it, we basically just want it to change the content that's actually displayed. It's pretty straightforward. So this isn't a super complicated component, but for the purposes of this talk, we're just going to talk about this. Okay, on to our first point. Reusable components should be self-sufficient. They should do one thing, they should do that one thing well, and they should do that one thing well consistently and also independently of the project that's using them. It should basically work as advertised out of the box. There doesn't need to be a lot of bootstrapping to get your project to use a reusable UI component the way that it should be used. So in terms of React specifically, this means that our reusable UI components should have enough state to be useful. So the components don't need to worry about the data that they're concerned about displaying. That's not part of the internal React component state. Because where the data comes from and what it might look like may differ from application to application. But the component doesn't care. There's a parent project around it that knows what form the data comes back from the API in and what the component expects it, and it kind of bridges the gap for the component. So our component doesn't care about the data, but it does care about the user interaction. And this is what I mean by having enough state to be useful. So in our example, our component cares about which tab the user selected and which one's currently selected. So knowing which tab is selected allows the component to process the data passed in from the parent project and render the appropriate tab. It's also going to consistently handle the tab navigation from one project to another. So having the internal state means that this behavior, this interaction, is going to work just out of the box. But the internal state doesn't need to be completely isolated from the parent application. So as we know with React, children and parent components don't necessarily have access to the internal state of one component. But here, I kind of want to let the parent project know that something's changed. So for example, if you're trying to log the user interaction in a parent project, I want to tell that parent project that, the users clicked on the overview tab or the trailers tab. So the component should have enough state to be useful, but you should also allow it to be initialized in a particular state. For example, here we can pass in the currently selected tab when the component's first rendered. But if you look at the rest of the component code, and this is kind of a simplification of what it would actually look like, but we're going to ignore the updates to the selected tab prop going forward. And the reason we're going to do that is because no matter what order the user does a certain set of interactions in each project, it should behave the same. But if you allow them to override it in the middle of the user interaction that's going on, the component's going to behave differently between projects. And that's not what we want when we're doing a reusable UI component library. Okay, that's the first point. So now we're going to talk about the second point, which is that reusable UI components should be easy to integrate with. So at a high non-React level, I want to just make the component interface very easy to understand. I want to make it easy for other developers to understand the touch points between their project and my reusable UI component. In terms of React specifically, when we talk about the interface, what we really mean are the props that a component expects. You don't really have to look at this slide. It's a little dense. Just an idea of what the props for our example is going to look like. So if we look at our example again, we might expect, probably want a title, a description, an image, two people looking a little stupid and confused, and also the tabs for the bottom of the component. So one of the first ways to make your component really easy to integrate with, or for other developers to understand, is to make it self-documenting. And this is something that React gives us as a framework. So basically, you can specify what your props should look like and what type they should be. So that's what we have on screen here, is all the props for our example component. You can also specify which ones are required. And actually, you can get really granular with these. So if you look at our tabs, we can not only specify that we want tabs, but we can specify that we want them to be an array of objects that have a key, a display name, and also a content attribute. And I really recommend looking at React's prop type documentation because it's actually very powerful, it's really extensible, and they even have information in there on how you can build custom validators for custom use cases. And so by defining your props like this, someone can quickly tell what they need to pass in to their component. And also, you can take advantage of React's warning system, which will emit a warning in the console for other developers saying, hey, you know what, you didn't pass in a title, and also your tabs are the wrong type. If you want to go one step further in self-documenting your components, there's a Gulp plugin called Gulp React Docs, which I wrote with some colleagues at Admiral. And this is a plugin that takes a list of React files and it's going to produce Markdown. So it will parse the prop type definitions in your component, the comments above those, and also your getDefaultProps function to generate a Markdown document that puts that all in a really easy to read format. And this helps because other developers also don't need to dig through your code just to find that one file that has all that information. Another way to make your components really easy to understand is to have as few props as possible. And so this does two things. This reduces the cognitive load on other developers that are trying to figure out how to use it, and it also translates into fewer touch points, which means at runtime probably fewer points of failure. So the first way to have as few props as possible is to reduce the number of props that you have. That seems redundant, but I'm getting to it. And so you're going to want to, by reducing the number of props you have, you can do that by defining flexible props. So basically, you're trying to support as many use cases as possible with as few props as possible. And in order to do this, you may have to internalize some of the complexity, but really, like I said, it's really important to make it stupid easy to use. So if we look at our component again, we're going to look at our title here, which has some text and also looks like an image for where it says special correspondence. In our component, this is our definition for the title prop. So one way that I could have done this is to have a prop called title logo source, which would have been a string, basically a URL that points to a logo that I might want to display, or a title string, which is just a string. But I actually chose to just have one title prop that can either be a string or an element. And so this supports more use cases because I can now have just a string, I can have a logo and a string, I could have just a string with special badging, for example, new episodes, come watch. So here, it's by having one prop, you can support more use cases, but also you can remove combinations of props that might not make sense to someone else. So it's kind of unclear what would happen if I pass in both title logo source and title string. Another way to have fewer props is to decouple them. So back to our example component, let's say that we don't want to have any tabs. We just want to show the title, the description, and the cover image. I could have added a hide tabs prop that basically overrides the tabs. But instead, I think the reusable UI component should take the responsibility of rendering the tabs intelligently. So instead, if I have no tabs that are passed in, or if I have an empty array, I'm just going to return null. I'm just not going to render anything. So this not only eliminates the need for an extra tab just to toggle the tabs on and off, but it's also going to decrease the likelihood of unexpected behavior because now we don't have one prop that relies on another, whether or not it's displayed, and so the component may not have bugs. Also, you're going to make it more resilient to developer error. Say someone didn't pass in any tabs, and then you try to render something, and you have an error. So by decoupling your props, you're removing combinations that don't make sense to other developers and that may be really prone to bugs. So if you still want to make your components easy to use, I recommend removing backdoors. So this decreases the likelihood of unexpected behavior, like I mentioned. And it's really more of an internal implementation detail than it is a prop type or interface issue. So let's say our component takes a tab events prop. In an earlier slide, we talked about letting the parent project know that someone's clicked on something. So in our div, here, we have an onClick handler that in the handle tab click function is going to call the onClick function passed in the tab events prop. Another way to do this would have just been to take the tab events prop and object spread it into the reactive. And this is bad for two reasons. So one, the developer now has a backdoor to reactive elements, so they can pass in an on hover or on focus or on whatever, which will lead to inconsistent behavior across projects and also potentially unexpected behavior for them. But also, this isn't super performant when it comes to React. So I've talked a lot about React components and props and, JavaScript. And that's one way to make components easy to use, but another way is to make sure that they're really easy to place in a parent project's layout. So this is the box model illustration that you'll find in your dev tools. And so if you want to make your components really easy to lay out, you don't want your components to have any unexpected padding or margin, basically just want the blue part that we have here. So your components should take up 100% width and height of the container element that they're in, because parent projects will often place them in a container to try and place them. But if you've got padding or margin, it's not going to be where they're expecting it to be, and they may need to start overriding the CSS in your component. So now that we have all of this code that's written in a, hopefully self-sufficient and easy to use way, how do we make it easy for others to actually use the code? So no matter what framework or build system or development environment that they're using. So let's say in your company you have a team that's using ES6 and Gulp and Browserify, and you have another team that's loading their assets just via script tags and style tags on the page. How do you make it easy for someone to use your reusable UI component in both of those teams? And that's to publish assets intelligently. What do I mean by that? So the first way to do that is to publish your assets to multiple places. So you can publish your component, the source code, to NPM or some sort of package manager. And you can also publish it to a CDN. And so by having it published in multiple locations, you allow other teams to pull in that component in whatever way works best for their development environment. So someone using Gulp and Browserify can NPM install it, or someone else who's using just CDN can just load it via a script tag on their page. You also want to make sure that your components are versioned. So you get this for free with NPM and semantic versioning. But when you're publishing to a CDN, you should make sure that you're publishing to version-specific folders or buckets or however you have your CDN organized. And this is so that if you introduce a non-backwards compatible version of your component, you're not automatically breaking everyone who's already using it or breaking their project. So if you're going to publish your assets for multiple teams to multiple places, you should publish transpiled assets in addition to your source code. So let's say, I'm writing my reusable UI component in JSX and ES6, but there's a team out there who's not using the same version of JavaScript and is maybe using Backbone. I'm going to transpile my code so that they can import it into their project, no matter what framework that they're using. You should also transpile, or in the case of styles, your CSS. And now this doesn't need to be done for every project, but if your styles are using static assets like fonts or images, you should, first of all, push them up to a CDN, and then you should also pre-process your styles to remove all of the relative URLs that you're using when you're developing your component, and replace those with absolute URLs that point to the asset on the CDN. And obviously, since you've published it and versioned it into different files and folders, you can publish different versions of your fonts and your images and everything like that. So in addition to transpiling, we also need to compile our assets. So for style sheets, let's say I'm using less and someone else is using Sass, how can they use my styles? And one way to do that is to compile my less into CSS, because they can import it into their Sass. And also other teams using the CDN can just load my styles via a style tag on their page. And for JavaScript, this actually is a little more complicated, but it basically just means compiling your code or bundling your code into a single file. And in order to do something like this, we need a dis.js file or an entry file, which looks something like this. So this file is going to import your top-level component, or for your reusable UI component, and it's going to attach that component to a global namespace. So when this is compiled into a single file, we have all of the individual components inside of the blob. And that way, we're also going to get rid of any JSX or ES6 that we're using. And so teams that are using your component via CDN can just load this via script tag. But doing this, you also need to remove any dependencies that you're using. So for example, Lodash. You can use a tool like Browserify shim to basically, it'll just assume that Lodash exists in the global namespace. And this kind of contradicts, make your component really easy to use, because it's adding friction to the other team to also pull in the dependencies. But this is actually much better than, let's say, if you compile Lodash into your component, you've got one version, and another team is using a different version, and they're clashing. they're probably going to end up having bugs that they have no idea where they came from. So that, I think, is a little bit more confusing than if you were to require them to bring in the dependencies themselves. So, recap slide. Yay. So by making the component easier to use, publishing our assets intelligently, basically publishing them to multiple places, versioning them, transpiling everything, compiling everything. This minimizes the amount of work that other teams need to do in order to get it to work. They can just, take it from the CDN or the package manager, and hopefully it'll work pretty seamlessly. And this drives adoption of your UI components. So we're done. So reusable UI components, like I said, regardless of whatever framework that you're building them in or whatever framework other people are using them in, should be, first of all, self-sufficient, and second of all, really easy to integrate with. And don't take this as a mandate. I'm not an expert. I just have opinions, which can sometimes be misconstrued as an expert. But I just want you to take these away and start thinking about how to build reusable UI components that you plan on sharing. That's it. Thanks. So I'm at Mars Josephine on Twitter. I'm going to take questions offline, so feel free to follow me. Send me any feedback, any questions. Compliments are great too. Drinks, awesome. Thanks.